All right, so here are the first 5 problems in this, or first 6 problems in the practice test. So here we're going to look for the first 5 terms of each of these sequences. And so essentially, what we're trying to find is A1, A2, A3, A4, and A5. And the idea is simple when you have an equation given in explicit form, we say. So for the first problem here, if we want to find A1, you simply just have to substitute a 1 for wherever the n is. So then the 1 here is just like the same 1 here because that n represents the same n there. So then A1 is just equal to 1 minus 9, which is just -8. A2 then is going to be 2 minus 9, which is then -7. A3 will be 3 minus 9, A4 will be 4 minus 9, and A5 will be 5 minus 9. So wherever that n is, we're substituting the 1, 2, 3, 4, and 5. So A3, 3 minus 9, which will be -6. A4, 4 minus 9, or yeah, 4 minus 9, -5. And then A6, or A5 will be 5 minus 9. 5 minus 9, which will be -4. And you can see the pattern already. It's going down by 1, or it's going up by 1. So usually when you catch on to the pattern, it'll be much easier to figure out what each term is. So let's look at the next one. So an is given by this equation, 1/2 n squared. So then, again, the same idea for the first problem. Wherever that n is, we're going to plug in a 1, 2, 3, 4, and 5. So then A1 will be 1/2 times 1 squared. Which will be 1/2 times 1, or just 1/2. A2 will just be 1/2 times 2 squared. So let me write A2 over here. Which will be 1/2 times 4, which will then be equal to 2. A3 will be 1/2 times 3 squared, A4 will be 1/2 times 4 squared, and A5 will be 1/2 times 5 squared. So let me crank them out right here. I'll try to I have to probably put some of these problems at the bottom, but let's just work through this one. So A3, 1/2 times 3 squared. So 1/2 times 9. So 9/2. A4, 1/2 times 4 squared. So 1/2 times 16. 8. And A5 will be 1/2 times 5 squared. So 1/2 of 25, so 25 halves. All right, let's look at number 8. And again, try these problems on your own once you're catching on, and then you can check in like to see if you're getting the right answer. So maybe pause the video before I do the problem and then try it on your own and then check in, unpause it. So let's look at problem 8. So 1/2, or so no, we have an is -3/2 to the n minus 1. I'm going to write them over here. So then a1 will be -3/2 to the 1 minus 1. Which is -3/2 to the 0. Anything to the 0, except for, 0, infinity, those sort of numbers, it's going to be equal to 1. So a1 will be 1. A2, -3/2 to the 2 minus 1, -3/2 to the 1, which is just going to be -3/2. A3, -3/2 to the 3 minus 1, -3/2 to the second. This will be -3 times -3 over 2 times 2. So then this will be positive 9/4. A4, -3/2 to the 4 minus 1, so -3/2 to the 3. So then -3 times -3 times -3 over 2 times 2 times 2. And well, let me just write it out in case you want to see this or you need a review of exponents. So you're multiplying, see the -3 by itself 3 times. So on top we would get a -27, and the bottom we would get 8. And A5, you're going to get -3/2 to the 5 minus 1, or -3/2 to the 4th. -3 to the 4th will be positive 81. 2 to the 4th will be 16. All right, now let's look at problem 9. So problem 9, we are given what's called the recursive form of a sequence. So looking at this, we're given that the nth term is equal to the an minus 1 term minus 2. See this n minus 1 subscript right here is referring to the term that came right before. So we're already told that a1 is 55. So if we want to find a2, working this down over here, what we do is we put a3 or a1 where this whole thing is. So where this entire expression is, which is 55, and then we subtract 2 from it, which will be 53. To find a3, we put a2 here, which is 53, and from there we subtract 2, and we get 51. A4, we plug in that, we put that 51 here, subtract 2, we get 49, and so forth. So that's the pattern. It's really just about understanding the notation. So let's look at number 10. Number 10, we got that A1 is 200 and that AN is 1/5 times AN minus 1. So A2 is going to be 1/5 times the previous term. So times A1. A1 was 200. So we're going to take 200 and multiply by 1/5. And that's going to give us 40. Then to find A3, we're going to multiply A2 or 40 by 1/5. And that'll give us 8. Find A4, we multiply A3 or 8 by 1/5, or yeah, by 1/5. And we get 8/5. And to find A5, we multiply A4, which is 8/5, by 1/5, and we get 8/25. So there's one more piece type, number 11. We have that A1 is -3 and that AN is equal to -3 times the previous term. So to find A2, we're going to take -3 and multiply it by A1, which was -3. Then we're going to add 1 to that. So A2, we're going to get 9 plus 1, which will give us 10. A3, we're going to take -3 and multiply it by A2, which is 10, then add 1 to it. So we'll get -30 plus 1, which will get -29. A4 will be then -3 times -29 plus 1. So that'll be -87 plus 1. So -86. And A5 will get -3 multiplied by A4, which is -86. And then add 1 to it. And we'll get -3 plus 80, -3 times 86 be 258. Hold up a second. I think, did I do this? Oh, I did this. Wow. Caught myself here. -3 times 8, -3 times -29 is +87. And +87 will plus 1 will be +88. Whoops. And then this instead will be +88 times -3. Then to that we add 1, so forget about this. So -3 times +88. -264 plus 1, which would be -263. Sorry about that. All right, but there you go for those first problems. All right, let's move on. All right, in problems 12 through 15, we're going to look for an explicit rule that gives you the nth term of each sequence. So in general, we're looking at two types of sequences. We're looking at arithmetic sequences, where we can have the nth term be given as the A1 term, or I like to use AM term, just in general, plus the common difference D times n minus 1, or times n minus m. Now, whenever you have the first term, you can also use just A1 always as that mth term. So then you can maybe see it as this form. Both of these work. I usually show my students this one first, and then as we practice it, they can see that the n doesn't matter. It could be anything, because that's why it says possible explicit rule. There's many rules you can use with this type of pattern. But for the most part, I'm just this one will make your life a little, simpler in the sense you can always, start with A1 if you have A1. Now, this is for arithmetic. Geometric, you can have the nth term be given by, again, AM times the common ratio R to the n minus m power. But again, you can use A1 always as an AM if you know what A1 is, just to make your life simpler. So then you can have this form. AN is given as, or AN is equal to the A1 term times the common ratio R to the n minus 1 power. They both work, but it really comes down to first determining if you have a geometric or an arithmetic sequence. So then when you have an arithmetic sequence, you can see that you're always going up by the same number. So here we're going by a -4. You're subtracting 4 each time. That means we have an arithmetic sequence. So we can jump to this formula. So we can write AN is equal to A1, which is -4, plus D, our D, or common difference, is -4, times n minus 1. This is essentially your answer. You can clean it up and reorganize, but this will work. So you can maybe rewrite this as -4 minus 4n plus 4. Which is just going to be 4n. AN is equal to 4n. Because -4 and +4 cancel. Okay, for the next one, you can see that you're multiplying by 4 each time. If we keep on multiplying by 4, we're going to generate the next term. So then this is a geometric sequence. So we can find the nth term, AN, as being equal to the first term, 5, times our common ratio R, which is 4, to the n minus 1 power. And that's your equation. For the next one, looks like we have a arithmetic sequence because we're adding 5 each time. So our common difference is 5. So we can say the nth term, AN, is equal to the first term, which is -24, plus 5 times n minus 1. Simplifying this, we get -24 plus 5n minus 5, which is just -29 plus 5n. And then for number 15, we have a geometric sequence, because see, we're not changing by the same number each time. We're changing by a ratio. And to find this ratio, if you can't just spot it, like, easily, what you can do is take 18 over 27 and simplify it. And you can find that the common ratio is equal to 2 over 3, because we can divide both of these by 9. You can always find it by dividing any two terms backwards. So you can go like, write r is equal to this, but it's also equal to 12 over 18, or 8 over 12, or even 16/3 over 8. You're going to get 2/3 for each of these, because you're multiplying by 2/3. So then our common ratio is 2/3. And so we're going to use this rule, where the nth term is equal to a1, which is 27, times 2/3 to the n minus 1 power. All right, there you go for those ones. All right, moving on to the next ones. All right, here we're gonna work on expanding each of these series and evaluating them. So let's take a look at the problems we got. We have 4 examples. So the first one, we have the series where each term is equal to k squared times -1 to the k power. So the idea really here is to understand, again, the notation. What this is saying is to add up the first 4 terms, a1, a2, a3, and a4. And this, in the red parentheses tells you how to generate each term. So a1 is going to be 1 squared times -1 to the 1. You put a 1 where that k is. Then we add this to a2. a2, we put a 2 where that k is. So this will be equal to 2 squared times -1 to the 2. a3, you put a 3 where the k is. This will be equal to 3 squared times -1 to the 3. And I messed up on the first one. Wow. Yeah, that should be a 1. Let me make that clearly. This should be a 1. My bad. So 1 where the k's are. 1, 2, 3. 1, 2, 3. Okay. And then a4. Will be equal to 4 squared times -1 to the 4th power. So see, again, you're adding a1, a2, a3, and a4. And the rest hopefully should just be a review of your algebra and order of operations. So then we do -1 squared, which is 1 times 1. So 1 times 1 is 1. Two squared, 4 times -1 squared, which is 1. And I messed up again on the first one. This should be -1. I think I said -1, but I wrote +1. A3, we take 3 squared, which is 9, times -1 cubed, which will be -1. A4, we do 4 squared, 16, times -1 to the 4th, will be +1. When we add these all up, And we'll get -1 plus 4 minus 9 plus 16. 3, -6 plus 16 will get 10. All right. All right, from 18, we're gonna add up the first 5 terms. So then let me go to the next line so I don't have to squeeze these in. So then A1, let me make parentheses so I don't have to spend more time switching markers or switching pens. So then A1 will go in here. We plug in 1 where that K is. So we have 0.5 times 1 plus 4. A2, we plug in 2 where that K is. So we get 0.5 times 2 plus 4. A3, we get 0.5 times 2 plus 4. A4, we get 0.5. Why do you know? I think I said 3, but I put 2 here. 0.5 times 4 plus 4. And A5, 0.5 times 5 plus 4. And then we should get 0.5 plus 4, which will be 4.5. 0.5 times 2, 1 plus 4, 5. 0.5 times 3, 1.5 plus 4, so 5.5. 0.5 times 4, 2 plus 4, we'll get 6. A5, 5 times 0.5, so 2.5 plus 4. So we'll get 6.5. Add these all up, we'll get, let's say, 10, 15, 21, 27 and a half. All right, number 19. We're gonna add the first 5 terms and we're gonna plug in 1 into wherever the K's are, add it then to A2, or you plug in 2, and you plug in 3, plug in 4, plug in 5. Expanding this, we'll get A1 to be -1 to the 1 plus 1. Times 2 times 1 minus 1. A2, -1 to the 2 plus 1. Times 2 times 2 minus 1. Plus -1 to the 3 plus 1 times 2 times 3 minus 1. Plus -1 to the 4 plus 1 times 2 times 4 minus 1. And A5 will be, I don't want to squeeze it in there, so let me move it to the next line. A5 will be -1 to the 5 plus 1 times 2 times 5 minus 1. Okay, so breaking this down, this is -1 to the 2, which will be +1. We'll get +1 times 2 minus 1, which will be 2 minus 1 is just 1, plus a2 -1 to the 3, which will be -1, times 2 times 2, so 4 minus 1, so times 3. A3 -1 to the 4th, +1. 2 times 1, 6 minus 1, 5. A4 -1 to the 5, which will be -1. 8 minus 1, 7. And A5 -1 to the 6, which will be +1, times 10 minus 1, so times 9. Add these all up, we get 1 minus 3 plus 5 minus 7 plus 9. So we get -2 plus 3 minus 7, -4 plus 9, we'll get 5. And for the last one, we just have to add the first 4 terms, where we have each term given by this equation here. We're going to add up 4 terms. Five times 1 over 1 squared. 5 times 2 over 2 squared. 5 times 3 over 3 squared. 5 times 4 over 4 squared. And then from here, we'll get 5 over 1, so just 5, plus 10 over 4, plus 15 over 9, plus 20 over 16. And then something that a term that they could all go into. Remember, you could find them all over the smallest factor of 16 and 9. And then you can find that they're both, you can always multiply them together, and they will see that they both go into 144. And so then you're going to have 5 over 1, but multiplying it by 144. So 5 times 144. It's 720 over 144 plus 10, 14, so 30. That'd be 30 or 360 over 144. And then 15 times 16. $256 over 144. And then 9 times 16 and 20 times 9. you have 180 over 144. Adding all the top up, get 180 plus 360 plus 256 plus 720. 1516 over 144. Not depending on how you're allowed to give your answer. I mean, I don't mind if it's left like this. But maybe they want it as reduced fraction, but again, to me, it's not a big deal. Right, so I'm gonna pause it here, and I need to get some water. And I actually just noticed something, I made a silly mistake. This should be 240. And then this changes it to let me just write the whole thing over. That means the top will be 1500 over 144. I think I showed my work because it would have been hard to catch that. Sorry about that. Let's move on to the next one. All right, here we have a couple of examples where we're gonna evaluate these series where we're given kind of the same goal, but we don't have to worry about expanding. These can kind of you can kind of figure out some patterns here. So we're gonna add the first 8 terms, and each term for this one is given as -5. So then that means A1 is -5. Means A2 is -5. Oops, A2 is -5. A3 is -5. Every term is equal to -5. So all you're really doing is adding -5 8 times, or you're just multiplying -5 by 8, which is just then -40. Here we're given the k squared as how we can find A1, A2, A3. So we're just squaring each of the integers from 1 to 10. So we're adding 1 squared to 2 squared to 3 squared to 4 squared, all the way to 10 squared. Now, this is something that maybe if you keep on going on in your math life, that will come up commonly, or not commonly, but frequently enough where you may learn some formulas, or you'll just have to you'll just be familiar with it, and it's always gonna add to 385. But again, you can always add them, up, quickly in your calculator or by hand, doesn't matter. And then here for 23, we have each term is equal to k, which means that A1 is 1, A2 is 2, A3 is 3, A4 is 4. So we're just adding the integers from 1 to 12. Because again, we're going from 1 to 12. And then we'll get 78. All right, let's now look at the next set we have. Okay, so here we're going to look at arithmetic sequences specifically, and we want to find the 11th term, it says. So for that, you can always brute force it, meaning you can always do a tedious calculation, or you can use this formula where the nth term is equal to am plus the common difference d times m minus n. Now, you may just sometimes always, or you may just see it, or maybe your teacher maybe gives it to you like this, where instead of am, they just write a1. And I usually will show my students first this one, because I want them to understand that the m doesn't matter. You just need to know any term and any other term in the sequence. If you know any other term in the sequence, you can find a formula for the nth term of a sequence given any other term. But that m, it's probably, just easiest to make it a1, but it doesn't have to be a1. But if you're given a1, then just go with it. So they're both the same formula, so to speak. So for example, here we have the arithmetic sequence 23, 19, 15, 11. And we need to look at the common difference, which is -4, because we're going down by 4 each time. The value of a1, if we want to just refer back to this, I wrote these backwards. Wow, I'm really messing up right now. This should be n minus m, and this should be n minus 1. N minus m and n minus 1. Sorry about that. So anyways, if we have a1, just go with this one. And we're given a1 in these 3 examples here. So then we just go ahead and we can use a1 is just 23. Then from there, just plug it in. So then an will be a1, which is 23, plus d, which is plus a -4, which is -4, times n minus 1. Now, if we want to find a11, we just plug in 11 wherever you see the n. So a11 will be equal to 23 minus 4 times 11 minus 1. And we'll get 23 minus 4 times 10. So 23 minus 40, we'll get -17. Right, 26. The common difference, let's start off with the common difference will be +2/5 because we're adding 2/5 each time to get to the next term. +2/5, +2/5, +2/5. A1 will be is 1/5. And then n, we're trying to find 11th term, so n is, we're going to make it 11. So then from there, we can find a11 by plugging in a1, which is 1/5, plus d, which is 2/5, times 11 minus 1. We just do the maths, 1/5 plus 20/5. And we get 21/5 for a11. 27, our common difference is going to be a positive 0.8. A1 is negative 9.2. And our n again is 11 because we're still trying to find the 11th term. So combining all these into our equation for an, what we're going to have a11 is equal to negative 9.2 plus 0.8, because that's our common difference, times 11 minus 1. So negative 9.2 plus 0.8 times 10. So negative 9.2 plus 8 give us negative 1.2. All right, here we're given two terms in a row. And so this is what I mean. This is where we can use this first equation to find the nth term. So we still start off with our common difference d, which is going to be 3.5. Now, see, we're not given the mth term. I mean, we're not given the first term, but that doesn't matter. Let's just make m equal to either 3 or 4. We'll just make m equal to 3. Our n is still going to be 11 because that's what we're trying to find. See, then from here, we're going to have A11 be equal to A3 plus 3.5 times 11 minus 3. Let me zoom out a little bit so you can see the whole thing. So writing it down here, A11 equal to A3 plus 3.5 times 11 minus 3. A3 is our 1.5. 1.5 plus 3.5 times 8. So A11 will be 1.5. 3.5 times 8 is 28. And so we'll get 29.5. Number 29, we're given A6 and A8. So then here I give my students another equation to find the common difference, which is that the common difference is going to be equal to n or an minus am over n minus m. And they can use this, or you should use this, when you're not just given two terms in a row, because you can't just subtract these two from one another, because they're not consecutive. You need to know A7 to find the common difference by just subtracting. But if you use this equation, you can find the difference as long as you're given two terms. So for example, let's make n equal to in this case, well, I don't want, let's not waste time writing. Let's cross this off so you can see what I mean. So an, let's just make it A8 in this case. And am, we'll make it A6 over 8 minus 6. So 21 minus 47 over 2, which is just negative 26 over 2. Which is negative 13. So the common difference is negative 13. And I did all the work just, to show you, but you can just do a lot of this in your head. But if you know the common difference now, we just go back to our formula. We know the common difference is negative 13. We want to find A11, so n is 11. And we'll make m, you can make m either 6 or 8, it doesn't matter. Let's just make it 8. And then we use our formula again for the nth term. So we can have A11 equal to AM or A8 plus D, so plus negative 13 times 11 minus 8. This will be then 21 minus 13 times 3, or 21 minus 39, and that'll be negative 18. All right, one more example of these ones here. See, we're given now A5 and A9. So we're given terms that are like 4 away from each other. Or I mean, 4 in terms of their place in the sequence. So then if we want to find the common difference, we can just take A9, which is 13, minus A5, which is negative 7, over 9 minus 5. So we'll get 20 over 4, and we'll get 5. And then from there, we can have an equation for A11. We'll make N11 again. And M, we can just make it 5. Then now we can find A11 by using our equation for AN. So A11 will be equal to A5 plus our common difference, D, so plus 5, times N minus M, so 11 minus 5. This will be equal to negative 7 plus 5 times 6. So negative 7 plus 30. And that'll be 23. All right. All right, about halfway through, let's feel free to take a break. Let's now look at the next set. 4 practice problems now with finding sums of an arithmetic series. So for this, we can use our formula for the sum of the first n terms, where we have Sn is equal to n times A1 plus An over 2. Okay, here we want to find S18. So our n is going to be equal to 18. A1 will be equal to negative 1. And then we have to find A18. So for that, we can refer to our formula for the nth term, where An is equal to Am plus D times n minus m. And again, if you have A1, you can always just use A1 in place of AM. So either one is fine. They're the same formula essentially, which I just went over in the previous examples. So A18 is going to be equal to A1, which is -1, plus our common difference D. We're going down by 4, we're decreasing by 4, so that's going to be -4 times 18 minus 1. So it's going to be -1 minus 4 times 17. So -1 minus 34, so minus 68, and -69. Now to find S18, we just plug in those values in here. So probably put it over here. S18 will then be 18 times -1 plus AN, or just minus 69 over 2, which will be 18 -1 minus 69, -70. -70 over 2 is just -35. So 18 times 35, we'll get -630. All right, next one, we want to find A12 or S12. So our N is going to be 12. A1 will be 1/3. A12 is what we want to find. So we're going to use this formula. So let me make a line here. So A12 will be equal to A1, which will be 1/3, plus here we're going down by 1/6, so which will be -1/6. Times N minus 1, or 12 minus 1. So this will be 1/3 minus 1/6 times 11. So 1/3 minus 11/6. So 2/6 minus 11/6. This is the same as 2/6. 2/6 minus 11/6 will be -9/6, which will be the same as -3.5, or no, not -1.5, -1.5. Okay, so we have the three things we need. So we just use our equation for S12. That will be equal to 12 times A1, which is 1/3, plus AN, so plus a -1.5 over 2 combining these. Well, I guess we can go back to the 6 because I'll make it a little easier to do the math, because we'll get 12 times 2/6 minus 9/6 all over 2. Factoring out these 12 over 6 is just 6, so this becomes 6 times 2/6 minus 9/6, so times the -7/6. And these 6 cancel, and you'll end up with just -7. Wow, all works out pretty nicely. All right, 33. Okay, so same idea. We're just given a different notation. We have to find the we have to find the sum of the first 15 terms. And this is actually makes it easier to find our A1 and AN because you can just plug in 1 and n into the equation here. So then A1 will be equal to negative 14 plus 3 times 1 because we're plugging 1 into here, which will be negative 14 plus 3, so negative 11. A15 will be then negative 14 plus 3 times 15. So negative 14 plus 45. That'll be 31. Our n is 15. So now we plug all these into our formula. So S15 will be equal to n, which is 15, times A1, which is a negative 11, plus A15, so plus 31, all over 2. So negative 11 plus 31 is 20, so 20 over 2 is just 10. So 150 times 10, so then we get 1, or 15 times 10, and we get 150. All right, one more practice of these. We're trying to find again the first 15 terms, or the sum of the first 15 terms. So then we need to find A1 again. A1 will be just equal to plugging in 1 in the 3 halves times 1 plus 10. So 1.5 times plus 10. So 11.5. A15 will be 3 halves times 15 plus 10. 45 over 2. So 22.5 plus 10. So 32.5. Our n is 15. And so to find S15, this will be equal to 15 times A1, which is 11.5, plus plus A15, which is 32.5, all over 2. So 15 times 33, 34, 44 over 2, or 15 times 22, or 15 times 22, which will be 330. All right, I'm gonna take a little bit of bathroom break. I'll be right back. So I'm gonna pause it, and we'll move on to the next set. All right, I'm back. So let's look what we got next. So now we're gonna look at some practice with geometric sequences. Chair is giving me issues. All right, so we want to find the 8th term of each geometric sequence, and let's refer to this formula, where the nth term of a geometric sequence is equal to am times the common ratio r to the n minus m power. Now again, you can always replace m with a1, so we can write an is equal to a1 times r to the n minus 1 power. I like to show my students, again, this formula first, because then they can understand that you don't need to make m1, which is helpful in case you're not given a1 directly. If you're just given any other term, you can just substitute that term for AM. But if you have A1, might as well just use A1. Okay, so let's go for the first equation. Let's look at the first example here. So we go from 40 to or from 40 to 4 to 0.4. So the common ratio here is 1/10. Now remember, if you can't find it, or you can't just see it easily, you can just divide any term by the term right before it. So you can do 4 over 40, and that'll be the same as 0.4 over 4, 0.04 divided by 0.4, and so forth. But you're still always going to get 1/10. But if you see it right away easily, then just don't waste your time with that. Okay, so to find A8, we're going to have A8 be equal to A1, which is 40 in this case, times R, which is 1/10, the 8 minus 1 power. So let's see, 40 times 1/10 to the 7th power. So 40 times 1 to the 7th, which is just 1, over 10 to the 7th, which will be a 1 followed by 7 zeros. Multiplying this by 40, this will be 40 over, I think we got, what do we got here? We got 10 million. 40 over 10 million. Which will simplify to 4 over a million, or 4 over half a million, which is a decimal. I think this will work out to be, this will work out to be an exact decimal. So point point 0.00004, or 0.000004. Me personally, I'm fine with my students leaving their answer like this. I actually don't mind if they don't reduce it as a fraction, because this is just like the tedious part and the stuff you learned in middle school, hopefully. But if you can, of course, simplify it, reduce it as far as you can. Okay, next one. We have 1/18, 1/6, 1/2, 3/2. So again, if you can't see the common ratio easily, we can just do 1/6 over 1/18, and you'll just get 1/3. And then we can just rely to our formula here. A8 will be A1, which is 1/18, times R, so times 1/3 to the 8 minus 1. Which will be 1/18 times 1/3 to the 7th. So 1/18 times 1 to the 7th over 3 to the 7th. 2187. This will be 1 over 18 times 2187, which will be over 39,366. Nice. Hold up, I made a mistake. Can anybody spot it? Common ratio is actually 3, because that's going to be 6 or 18 over 6, because when you flip the fraction, it'll be 1/6 times 18 over 1, which is 3 over 1, which is just 3. Wow. So let's do a bonus problem. So this should be our common ratio. So let's go through it correctly. A8 will then be 1/18 still, but inside here will just be 3. 3 to the 8 minus 1, or 3 to the 7th, which will be, instead of the 21/87 being on the bottom, will be on top. So this will be 1/18 times 21/87, or 21/87 over 18. It'll be 121.5, 121.5. My apologies about that, but it's just some extra practice. Anyways, all right, next one, we go from -16 to -8 to -4 to -2. So the common ratio here, we go -8 over -16. It'll give us 1/2. And yes, I'm sure about that. I'm double checking. Yeah, 1/2 makes sense. Multiplying by 1/2 gives you the next number. And then so A8 will then be A1, or -16 times 1/2 to the 8 minus 1. -16 times 1/2 to the 7th. -16 times 1 to the 2, 4, 8, 16, 32, 64, 128. So -16 over 128. I'm gonna divide both those by 4, right? 64, 32. Both those by 8, actually. So this goes 2 over 16, I think, right? 128 divided by 16, yeah. So this is just -1/8. But again, me personally, I don't mind too much if my students don't reduce their fraction all the way. So either of these answers is fine with me. One more of these guys. All right, the common ratio here. And this should be a +12, and this should be +48. I didn't really copy that correctly. So then the common ratio here will be then a -2. This 12 over -6 is -2. -24 over 12 is -2. And so then A8 will be A1, or -6 times -2 to the 8 minus 1 power, or -6 times -2 to the 7th power, or -6 times -2 to the 7th. We just did 2 to the 7th. It's be -128. So 128 times 6 will be a +768. All right. All right, coming down to the final more problems, or yeah, like 12. I think we got like 12 more. Okay, now we're looking at geometric sequences where we're given 2 terms only, and we have to find the 9th term. Okay, so this is see, this is where my other equation for the nth term, where we have an is equal to am times r to the n minus m power becomes useful. Because even though we don't know a1, we can just find the nth term by using any other terms. So for example, our common ratio here will be 96 over 24, which will be 4. And then a9 will be equal to, let's just make it a3 times r times 4 to the 9 minus 3 power. So this will be equal to 24 times 4 to the 6 power. So 24, 4 to the 6 is 4,096. 4,096 times 24 will be 98,304. So you see, you don't have to waste time on finding a1 if you know how to use this one. So for the next one, we have a1 and a2. So finding r, we can go ahead and do negative 4/3 divided by 2/3, which will be negative 4/3 times 3/2. These 3's cancel, so we get negative 4 over 2, and so our common ratio is negative 2. And then so a9 will be equal to, see, in this case, we are given a1, so we can use a1 in place of am. We can go a1 times r, which is negative 2, to the 9 minus 1 power, which is going to be 2/3 times negative 2 to the 8th power. 2 to the 8th power is 256. It's still positive 256. This will be 512 over 3. All right, now here we're given two terms, but they're not consecutive. So you can't simply divide one by the other to figure out the common ratio. But I have another equation that I give my students, which is just this equation solved for r, which is that r is going to be equal to the n minus m root of an over am. So if you don't have r easily found by dividing, you can use this no matter how far away the terms are. So for example, in this case, r is going to be equal to 6 minus 4 and an m over a6 over a4, which is you're trying to find the second root, which is just a square root of negative 4 over negative 1. So we don't even need that 2 there because the square root is usually implied when there's no x or there's no power there. So we're just trying to find the square root of 4, which is 2. Then from here, we can now go ahead and find a9 by making a9 equal to, and again, we don't need to have a1 because we can make this am. We'll make am, we'll just make it a4 times the common ratio r, which is 2 to the 4 minus 5th power, or 9 minus fourth power. A4 is -1 times 2 to the fifth power. This would be -1 times 2, 4, 8, 16, 32. Which will just be equal to -32. All right, and one more of these. So again, we're not given two terms consecutively in a row. So we find the common ratio with this. So then R will be equal to the 6 minus third root of A6, or 500, over 4. So this will be the third root of 500 over 4, so 125. So what number to the third power, what number times itself 3 times will give you 125, and that'll be equal to 5. That's 5 times 5 times 5 is 125. And then we can now find A9. And make an A9 equal to, let's just pick A3 times R, which is 5, then 9 minus 3 power. A3 is 4. 4 times 5 to the 6th power. 5 to the 6th power is 15,000. 625 times 4 is 62,500. Oof. Almost there, so hang in there. All right, so now we're going to look at finding sums of geometric series, and we're going to look at n partial sums. So then for this, we're going to use this equation where the sum of the first n terms is going to be equal to A1 times 1 minus r to the n over 1 minus r. Okay, so let's look at the first problem. We're going to find S5, the sum of the first 5 terms, which is like kind of, well, not pointless, but I wish they asked for like a larger sum. But anyways, we already have the first 4. But this will be then A1, which is going to be 1 times 1 minus r, which is 1/3, to the 5th power, all over 1 minus r, all over 1 minus 1/3 then. The 1 out here is not going to matter. So we're just going to have 1 minus 1/3 of the 5th. 1/3 of the 5th is going to be 1 over 243. 1 minus 1/3 is 2/3. One minus 243 will then be 242 over 243, all over 2/3. Doing the math, this will be 242 over 243 times the reciprocal of the denominator, so times 3 over 2, which then becomes, reducing this, dividing that by 3 will give you 81. Dividing this by 3 will give you 1. Dividing that by 2 is 1. Dividing this by 2 is 121. And so we get 121 over 81. The next one, we're trying to find S6, so the sum of the first 6 terms. So in this case, we have S6 equal to A1, which is negative 4/5, times 1 minus, the common ratio here will be negative 10. Because you're multiplying each time by negative 10. So negative 10 to the 6th power, this n is 6, all over 1 minus negative 10. Okay, so then this will be negative 4/5 times 1 minus negative 10 to the 6th. Negative 10 to the 6th is just a 1 followed by 6 zeros. And that'll be a positive 1 million. 4, 5, 6, 1 minus a positive 1 million. All over 1 minus negative 10, which will be positive 11. So on top, you have 999,999 all over 11 times 4/5, or times negative 4/5. Negative 999,999 over 11. All right, doing the math. 999,999 divided by 11. So we get negative 90,909 times negative 4/5 all over 1 if you want to look at it as a fraction. So that times 4. Will give you 36 or 363,636. Divided that by 5 will give you 72,727.2. A negative, actually. Negative 727,000. Negative 72,727.2. And I meant positive 72,727. All right. All right. The next 4, or next 3, yeah, next 4. It's same idea. It's just given in a different notation. So we just have to know how to read it. So let's look at term 50. So for here, we're looking for the sum of the first 8 terms. So we're trying to find S8. Wrong pen. And that'll be equal to A1, which we can find by plugging 1 into the power of K. So A1 will be 4 to the 1 minus 1, or 4 to the 0, which will just be 1. And R is going to be what's inside this parentheses. So R is 4. And then so S8 will be then be equal to 1 times 1 minus 4 to the 8. All over 1 minus 4. It'll be 1 minus 4 to the 8th is 65536. All over negative 3. We'll get negative 65535 over negative 3. I think works out evenly. Yeah, positive 21,845. All right. 51. You have the sum of the first 8 terms. No, we don't have some of the first 7 terms, is what I meant. So we're going to have S7 be equal to A1. You plug in 1 into there. You'll get that A1 is negative 2 times 5 to the 1 minus 1. So negative 2 times 5 to the 0. So negative 2 times 1, which will be negative 2. And the R will be the 5 here. So then the sum of the first 7 terms will be A1, which is negative 2, times a little separation here. Negative 2 times 1 minus R, or 5 to the 7th power, over 1 minus 5. 5 to the 7th power is 78,125, all over negative 4. Can't forget about this negative 2 out there. Almost forgot to put all this times negative 2. And so we'll get negative 2. 1 minus 78,125 will be negative 78,124, all over negative 4. 8,000. That divided by negative 4. And we'll get negative 2 times a positive 19,531, which will be then negative 39,062. All right, 2 more of these. So 52. Flip this over. The sum of the first 6 terms, S6. Finding A1, we just plug in 1 into there again. We get 60 times negative 1/2, the 1 minus 1. So 60 times negative 1/2 to the 0. 60 times 1, or just 60 then. And then R will be equal to that negative 1/2. And so S6 will be equal to A1, which is 60, times 1 minus a negative 1/2 to the 6 power over 1 minus a negative 1/2. This will be equal to 60 times 1 minus negative 1/2 to the 6 will be a positive 2, 4, 8, 16, 32, 64. So positive 1 over 64, all over 3 halves. Which will be equal to 60 times 63 over 64 over all over 3 over 2. Just doing the math, going down here, we get 60 times 63 over 64 times the reciprocal of 3/2, so times 2/3. Reducing 132 becomes a 121. So then we just get 60 times 21 times 1 on top. 60 times 21. So 1260 on top, all over 32. And you can leave it like this, or you can reduce it or change it into a decimal, and you'll get 39.375. Either answer is fine with me. All right, last one of these. Guess I can just do it right here. All right, A1 will be 18 times 1/2 to the 1 minus 1, or 18 times 1/2 to the 0, or 18 times 1, which is just going to be 18. R will be 1/2. What's inside that parentheses? And we're trying to find S5. So S5 will be A1, which is 18 times 1 minus 1/2 to the 5th over 1 minus 1/2, which is then 18 times 1 minus 2, 4, 8, 16, 32 times 1 over 32 over 1/2, which is 18 times 31 over 32 over 1/2. Breaking it down, we get 18 times 31 over 32 times 2 over 1. Reducing that, 16. So 18 times 31 times 1 on top. It's 558 over 16. And that as a decimal will be 34.875. All right, almost done. Just couple more problems. Final set, last 6. Here, we're going to find the sum of each of these infinite series. These are geometric, and for that, we're going to use the formula where the sum of the infinite series of terms will usually be written as, it's going to be easier than I'll just tell you this than the one we just used, which is nice. This will be equal to A1 over 1 minus R. Okay, so let's get through this. Let's look at the first one. Here we got, let me grab some scratch paper. $56. So S sub infinity will be then, A1 is negative 2700. over 1 minus r. R in this case is just going to be a negative 1/3. Because again, you're multiplying by negative 1/3 to get the next term. And this will be negative 2700 over 4/3. Doing the math of fractions, this is negative 2700 over 1 times the reciprocal of 4/3, so times 3/4. I believe that'll be, what, 8100, right? Yep, so 8100, or negative 8100 over 4. And that's just negative 2025. That's not a 25. I don't know why I do that. Negative 2025. All right, next one, 57. For this one, A1 will be that negative 1.2 here, so that goes on top. 1 minus r. R here will be 1/10. So we have negative 1.2 over 9/10, or negative 1.2 over 0.9. Doing the math, we're going to get a repeating fraction. To avoid this, I like to prefer, let's just change these into fractions. We can change this into negative 12 over 10. And that can be, this can be 9 over 10. And so you get negative 12 over 9, or negative 4/3. For 58, we have S sub infinity will be A1, which will be negative 49 over, common ratio here looks like it's going to be 6/7. But again, we can figure it out by dividing. What we can do is you can go R is negative 42 over negative 49. Dividing them both by 7. We'll get negative 6 over negative 7, or 6/7. Yeah. And so then we'll have this over 1 minus 6/7. Then doing the math, negative 49 over 1/7. This will be negative 49 over 1 times 7 over 1. It'll be 343 on top, so negative 343. There's 3 more. $59. I guess I can do that one over here. S sub infinity will be A1 will be 4. 1 minus r. R is going to be 4. No, 1/5, right? Yeah, 4/5 over 1. Yeah, 1/5. So 1 minus 1/5. So 4 over 4/5. So this will be 20 over 4. which will just be 5. All right, 60, we have 9 over 3 to the k. Now we have the series notation. My computer just glitched. Sorry about that. So then we want to find A1 like usual. So then we find A1 by plugging 1 into k. So we get 9 over 1, or 9 over 3 to the 1, which is just 9 over 3, which will be 1. And the R is not so obvious because we're not given it in this like notation, but you can still find it by just, let's figure out what A2 is and what A3 and A4 if you need to. A2 will just be 9 over 3 squared, which will just be 9 over 9, which will just be 1. A3 will then be 9 over 3 cubed, which is 9 over 27, or just 1/3. So now that you're generating a couple of terms, you can see more easily that R is just going to be 1/3. Then from here, we can use our equation for the infinite sum. So S sub infinity will be equal to A1, which is 3 over 1 minus R. So 1 minus 1/3. So it's 3 over 2/3, which will be 9 over 2, which will be 4.5. And for the last guy here, A1 will be plugging 1 into k. We get -7 times 3/5 to the 1, which will be -7 times 3/5, or -7 times 3 over 5. It'll be -21 over 5. R is just going to be that 3/5. And then so S infinity will be A1, or -21 over 5, all over 1 minus 3/5, which will be -21 over 5 over 2/5, -21 over 2, because again, using fraction math, this is going to be the same as -21 over 5 times 5 over 2. These 5's cancel, and you get -21 over 2, which is just -10.5. All right, we are done. Nearly 50 practice problems. Wow, that's a lot. So I hope that helps. So let me know if I can improve. Any feedback will be very helpful. And if I made any mistakes, let me know too. I'm trying my best. Sometimes I'm not perfect, but yeah, just let me know. And if you like the video, of course, give me a thumbs up and subscribe, and I'll see you guys later.